Greetings. Welcome. We'll be looking at lesson 6.1 and 6.2 this video. So, fun story. Took a short nap because I woke up at 5 in the morning and almost slept through the starting time. But that being said, I checked and I had not received any questions for this lesson. So I am going to do a selection of questions from 6.1 and 6.2. I think I'll plan to probably do 4 to 5 questions. If anybody has questions specifically that they would like me to go over, you can ask in the live chat. Otherwise, I'll go through these 5 questions in the stream, and perhaps you can check up on them if you're having trouble as you go through, and then we will call it a day. So let me take a moment and just pick out a question to start with. I'm just taking a quick glance at some of the homework that has been assigned. Let's start with 6C, just because I think it might be a good overall introduction to finding the non-permissible values. So that is on page number 318. So page 318, 6C. And the question is simplify and state the non-permissible values. So it's x minus 7 times x plus 7 divided by 2x minus 1 times x minus 7. Okay, so we will start here. I hope everybody is having a good day on this fine Thursday. I'm certainly feeling well rested. Okay, so we are going to want to reduce any factors that are in the numerator and denominator. So if anything is in the same in the numerator and denominator, we can divide them and get 1. But before we do that, we should look for our non-permissible values. And our non-permissible values are going to come from any factors that are in the denominator of this expression. I'm just checking my live stream. I don't know if what I'm typing is showing up. Awkward pause. There we go. Okay. So I'm going to want to look for factors that are in the denominator. So I have 2x subtract 1. So if 2x subtract 1 was equal to 0, we would have division by 0. So we have to ensure that that does not happen. So that means that 2x cannot be equal to 1, and therefore x cannot be equal to 1/2. The other factor in the denominator here is x minus 7. So I want to make sure that x minus 7 is not equal to 0, because if it was, then we would have division by 0. So in that case, I want to make sure that x is not equal to 7. So those are going to be my non-permissible values. Now we're going to reduce any factors in the numerator and denominator. So x minus 7 divided by x minus 7 is equal to 1. So that is provided that x is not equal to negative 7. So what do I have left over? So in the numerator, I have x plus 7. In the denominator, I have 2x minus 1. So my answer is x plus 7 times 2x minus 1, provided that x is not equal to 1/2 or 7. So I'd probably call that a fairly straightforward style question, especially since it's already been factored for you. But that just highlights the importance of looking in your denominator for non-permissible values. Let me look through the homework and pick one that's perhaps a little more challenging. happy to accept suggestions in the chat if you have them. Otherwise, I'm looking at something from number 8 on 318. Perhaps we'll do C. Perhaps we'll do them both. Well, we'll do C anyway, see how it goes. Okay, so 8C. So page 318, question number 8C. So this is b squared plus 2b. Wow, okay. B squared plus 2b subtract 24 is equal to 2b squared subtract 72. All right. So we want to factor it, and we want to figure out what the restrictions are, so what the non-permissible values are. So looking in the numerator, this looks like a standard quadratic, which perhaps could be factored. We could also use the quadratic formula if we wanted to figure out what those factors were in order to factor it. Probably not necessary in this case. Seeing that we have a negative for our constant term, so these terms will have to be a positive and a negative. So I want two numbers that multiply to give me a negative 24, add to give me 2. So I think that'll be a 6 and a negative 4. So they add to give positive 2 and they multiply to give negative 24. So those are the factors in the numerator. In the denominator, I see I have a factor of 2. Let me factor that out first. That leaves me with b squared minus 36. And observing the denominator yet again, b squared minus 36 is the difference of squares. So now we have b plus 6 times b subtract 4 divided by 2 times b plus 6 times b minus 6. Well, once again, we're going to want to look at our denominator to figure out what our non-permissible values are going to be. So one possibility, we want to make sure that b plus 6 is not equal to 0, so therefore b cannot be equal to a negative 6. And we want to make sure that b minus 6 is not equal to 0, and b cannot be equal to 6. Note that we don't have to do anything with the 2. We have to make sure that 2 is not equal to 0 as well. Well, done. It's not a 0. So we just have to worry about the factors that have variables in them. Okay, so those are going to be the non-permissible values. Now, do we have any factors in common in the numerator and the denominator? So we do. We have b plus 6. So b plus 6 divided by b plus 6 is equal to 1, provided that b is not equal to negative 6. So what are we left over with? In the numerator, we have a b minus 4. In the denominator, we have 2 times b subtract 6. So depending on your teacher, they may prefer that left in factored form, or they may prefer that be written as 2b minus 12. I'd probably accept either one. So with the caveat that b cannot be equal to negative 6 or b cannot be equal to a positive 6. I was going to go over 8f as well. I'm wondering if maybe I should just focus on the multiplication and division questions instead. Check the time. I don't know. Let's do 8f. What the heck? And we will we'll call that an end of the questions on the 6.1 topics. (8f) on page 318. So question number 8f. So this is 5 times the expression x squared minus y squared is equal to x squared minus 2xy plus y squared. All right. Numerator is very straightforward. X squared minus y squared is the difference of squares. This will be x plus y times x minus y. Denominator is probably not, or perhaps not as easy for you to notice, but we have an x squared here. We have a y squared here. I don't know why I changed the color there. Stop it. And I note that we have a negative here, and indeed it's negative 2xy. So if we just expand this expression that's on the right, we have x times x is x squared, x times negative y is negative xy, negative y times x is negative xy, that gives us our negative 2xy, negative y times negative y is a positive y squared. So you can see that the expression on the left factors to the expression on the right. Probably your hint is that you would expect one of these two factors to probably be in the denominator, given that this is a textbook question, if you had a little difficulty seeing those factors. Given that we only have one factor in the denominator and it is repeated, so this is basically x minus y squared, we just have to worry about that one restriction, that x minus y cannot be equal to 0, x cannot be equal to y. So we have a factor that is in common in the numerator and denominator. So x minus y divided by x minus y is equal to 1, provided that x is not equal to y. So therefore our answer is, and I'll do this one expanded since I did the previous one not expanded, I guess. So 5x plus 5y divided by x minus y with the restriction that x cannot be equal to y. Okay. So those are a subset of the questions on 6.1. So as I mentioned, I didn't receive any questions from the forum, so I just decided I'd pick a few and work through them. So let's take a look at 6.2 now. Just going to observe the ones that were assigned for a moment here and see if I can pick 2 or 3 suitable questions to go over for you. Again, if anyone is in the chat and wants to suggest one, I'll be happy to do that. Let's see. Let me do question number 2. B, I guess. So this is question number 2B. I believe it's on page 327. Page 327, number 2B. And this is a plus 3 divided by a plus 1 times a squared minus 1 divided by a squared minus 9. Okay, so we're going to factor this expression completely, simplify it, and state any restrictions, any non-permissible values. So before we look for those non-permissible values, let's try and factor each numerator and denominator as much as possibly can be factored. So for the first expression, there is no more factoring that needs to be done here. So this is just a plus 3 divided by a plus 1. Since these are being multiplied, we can multiply all of the factors in the numerator together. So if we take a squared minus 1, note that this is the difference of squares. This will give us a plus 1 times a minus 1. And a squared minus 9. Note again that this is also the difference of squares. This will give us a plus 3 times a minus 3. Now we need to simplify any factors that these two that are in common in the numerator and denominator. But before we do that, this is the step where we have to look at the denominator and see if we have any factors that could cause it to be equal to 0. We've got 3 of them. So if a plus 1 were equal to 0, then we would have division by 0. So therefore, a cannot be equal to negative 1. If a plus 3 were equal to 0, that would be division by 0, so a cannot be equal to negative 3. And if a minus 3 were equal to 0, once again, division by 0, so a cannot be equal to 3. I listed the work for these. I would probably consider that an optional step, and I would assume that your teachers would too, provided that you list the restrictions at the end. Okay. So what factors are in common? So we have a plus 3 divided by a plus 3, that is equal to 1, provided that a is not negative 3. And we have a plus 1 divided by a plus 1, that is equal to 1, provided that a is not equal to negative 1. So what's left over here? We have an a minus 1 in the denominator. We have an a minus 3 in the denominator. So this is a subtract 1 divided by a subtract 3, provided that a is not equal to a negative 3 or a negative 1 or a positive 3. So that's 2b. I think for the most part, these multiplication ones are... Oh, just close my digital textbook. I think for the most part, these multiplication ones are all very similar, other than they might have varying levels of factoring that you are required to do. All right, let's find a division one. I think 8a is the first division one that's posed. So why don't we start with that? Page 327. Question number 8a. So this is express each quotient in simplest form. And state any, or it says identify all non-permissible values, so you want to state any restrictions. Okay, I'll start that momentarily. If you're working alongside me, you can take a moment and copy it down. Okay. All right. So, guess we're gonna have to start by factoring this expression. So 2w squared subtract w subtract 6. Now, if you're using a standard factoring method and you're not using the quadratic formula or completing the squares, there's any number of ways that your teachers may have taught you to do this. So I think when I was doing the homework, I used this method. We want two numbers that multiply to give a times c, which is negative 12. And we want two numbers that that add to give a negative 1, which is the b value. And I can determine that those numbers are, I think, negative 4 and positive 3. So we add those, and that gives us a negative 1. We multiply those, and that gives us a negative 12. So that looks okay. All right. So I'm going to draw a box here. I'm going to put my a value in the top left corner. I'm going to put my c value in the bottom right corner. And then that negative 4 and positive 3, I'm going to use that to decompose that. So that's a negative 4w and a positive 3w. If you're just looking at doing this quickly, you might leave the w's out. So what we want to do is we want to look across and see what factors are in common here. So we have a factor of 2 and we have a factor of w. And looking at the second row, it looks like we have a factor of 3. So our first factor is going to be 2w plus 3. And now we're going to want to look down. So 2w squared and 3w, they have a w in common. A negative 4w and a negative 6, that has a negative 2 in common. So my second factor will be w subtract 2. So there is my factored expression on the left. And it looks like there's nothing further to factor on the right-hand expression. So we're going to want to now reciprocate this. A little bit disappointing that normally this denominator here would produce an additional restriction, but it's not going to matter because that restriction is already taken care of on the left. Okay, we're going to want to reciprocate this expression on the right since it's being divided. So 2w plus 3 times w minus 2 divided by 3 times w plus 2 multiplied by the reciprocal of 2w plus 3 divided by w plus 2. So that will be w plus 2 divided by 2w plus 3. I did this work for factoring on the side here, so I'm just going to highlight it over here. All right, what factors do we have in common in the numerator and denominator? So we have a 2w plus 3. We have a w plus 2. So it looks like when we have reduced any factors in common in the numerator and denominator, this will be w subtract 2 minus 3. But we have to look at this point in time, we have to identify all of our non-permissible values, and we're going to find those non-permissible values in the denominator, and we're going to find them in the numerator of any expression which was divided, because when we divide, it's like multiplying by the reciprocal, and when we reciprocate 2w plus 3 will be in the denominator of our reciprocated expression, as you can see down here. So we have to consider all of those as non-permissible values. I'll identify them up here. So w plus 2 means w cannot be equal to negative 2 is one possibility. W cannot be equal to negative 2 is a possibility here, but that's just a repetition. And 2w cannot be equal to negative 3, so w cannot be equal to negative 3 over 2. So we have w subtract 2 divided by 3, with the restrictions that w cannot be equal to negative 2 and negative 3 over 2. Note that by the time we have this fully simplified, both of those restrictions have kind of been reduced to the point that we would not be able to identify them just by looking at our simplified expression. Okay, I will choose one more, and then I'll see if there's any questions in chat. Otherwise, we will stop it there. So let me look through the assigned questions. I mean, there's certainly some that are longer than others, but I think it's all mainly down to factoring. Guess we'll end on 8C. So this is on page 327, I'm guessing? Yeah, 327. Question number 8C. So we have 9x squared subtract 1 divided by x plus 5 And we're going to divide that fraction by 3x squared, subtract 5x, subtract 2, divided by the expression 2 minus x. Okay. So let's start factoring as many of these things as possible. So 9x squared subtract 1. This is the difference of squares. So I'll have 3x plus 1 times 3x minus 1. Oof. In the denominator, this was an x plus 5. And that is divided by, well, looks like there's an expression that can be factored. I'll work this out longhand up here. So we want two numbers that multiply to give a times c. That's a negative 6. We want two numbers that add to give b. That's a negative 5. I believe that's going to be a negative 6 and a positive 1. So they add to give negative 5. They multiply to give negative 6. Okay, we're all right. So let's do the box. A goes in the top left corner, so that's 3x squared. C goes in the bottom right, that's a negative 2. And we'll use decomposition. Well, I can already tell I wish I gave myself more space on the right-hand side. So 3x squared and 1x, they have a factor of x in common. Negative 6x minus 2, they have a factor of negative 2 in common. So we have one factor of x minus 2. And then going down, so we have 3x squared and a negative 6x. So that's a 3x in common, and we have a 1x subtract 2. So that's just a 1. So we have 3x plus 1. And that's all divided by 2 minus x. Now, just by looking at all of these other factors, I see that they all list the x first. So I'm going to factor the negative sign out of here so it's written in the same way as the other factors. That will give me an x minus 2 inside the brackets here. So if I have a negative times x, I get negative x. Negative times negative 2 is positive 2, so I can see that's the same thing I had above. All right. So let's move down. And before we reciprocate the expression on the right-hand side, actually, I will reciprocate it first, and then I'll go back and look for the non-permissible values, I think. So expression on the left, or the fraction on the left stays the same. And we're going to want to reciprocate the one on the right. X minus 2 times 3x plus 1. Okay. And at this point in time, we're going to start simplifying. But before I do, let me check for my non-permissible values. I'm going to need the denominator of all of the fractions. So x plus 5 would cause that denominator to be equal to 0, so x cannot be equal to negative 5. Looking at the one on the right-hand side, x cannot be equal to a 2. But since I'm dividing this fraction on the right-hand side, I also need to look in the numerator of that fraction. So this gives me x cannot be equal to 2, which I believe is just a repetition. But this one on the right-hand side gives me 3x cannot be equal to negative 1, so therefore x cannot be equal to negative 1/3. So those are going to be all of my non-permissible values. Now let's do some simplification. And then we will list our final fully simplified expression and list all of the non-permissible values when we do. So we have an x minus 2 divided by an x minus 2. So that divides to give 1, provided that x is not equal to 2. And I have 3x plus 1 divided by 3x plus 1. That divides to give 1, provided that x is not equal to negative a third. So then, what am I left with? I'm left with a negative symbol here. And I'm left with 3x minus 1 here. So expanding that out fully, that gives me negative 3x plus 1 in the numerator, divided multiply x plus 5, and then I have to be cognizant of my restrictions. So x cannot be equal to, so listing them from least to greatest, x cannot be equal to a negative 5, x cannot be equal to a negative 1/3, and x cannot be equal to 2. Check my solution key and make sure that I ended up with the same thing when I worked this out before. Yeah, looks good. Great. Okay. So that is 6 questions, I believe, from the homework that was assigned. Like I said, I didn't receive any specific questions, so I just decided to do a sample of some of the things that were assigned to you. So coming up next is 6.3. I'm guessing I'll probably assign that one either on Wednesday or Thursday of next week. Maybe I'll go with Wednesday. Thursday doesn't seem to be a popular day. Okay. So I hope everyone is having a reasonable week. Hope you're all staying safe. Hope everyone is in good health. I guess I'm going to go work on my master's course is probably what I will do now. Okay. Take care, everybody. Stay safe, and I will see you next week.